Welcome to the Deep Dive. Today we're going to investigate Robert Lazar and all that stuff about alien spacecraft propulsion.
Sounds intriguing.
Yeah, we've got some source material,
Okay.
an addendum to a research paper
Right.
that dives into Lazar's claims.
Okay.
So we're going to try to see if this addendum gives any scientific weight to Lazar's claims about element 115, gravity A and gravity B. I'm more of a pop culture guy myself,
Okay.
not really a physicist.
Oh,
I'm really counting on you
okay.
to walk us through this complicated stuff.
Yeah, happy to help break it down. It does get
Yeah.
pretty dense.
Let's jump right in. The author, Ricardo C. Storti, actually managed to validate Lazar's gravity B wave frequency
Right.
in his previous paper.
Hmm.
He used something called quantized Fourier harmonics,
Okay.
which sounds very complicated.
Yeah.
Could you give us a simple explanation?
So imagine like a sound wave or a light wave, and you've got this complex waveform. Fourier harmonics, it's a way to break that wave down into simpler waves.
Okay.
Kind of like separating the instruments in an orchestra.
I see.
So in this case, Storti used this technique to analyze that gravity B wave frequency that Lazar described.
Right.
And he found that it can be represented by this specific combo of these simpler waves.
So does that mean that Lazar was right about gravity B?
Not quite.
Oh,
It's not that simple.
right.
Storti is very careful to say
Okay.
that validating the gravity B frequency doesn't prove Lazar's entire story. It doesn't require
Gotcha.
element 115 to even exist.
Right.
Doesn't confirm anything about Area 51,
Okay,
government conspiracies, or any of that.
Right.
It simply shows that that specific frequency that Lazar described has a mathematical basis using this technique.
That's an important distinction. So the math checks out for gravity B,
Hmm.
but it doesn't automatically validate everything else Lazar claimed.
Exactly.
But here's what I find really interesting.
Hmm.
Storti mentions that Lazar predicted a quantum property of Earth
Yeah.
17 years
Right.
before science could even confirm it.
Right.
That seems like a pretty big deal.
It's definitely eyebrow-raising.
Yeah.
It suggests that he may have had access to some knowledge that wasn't publicly available.
Right.
Where he got that knowledge?
Yeah.
That's a whole other question.
Yeah, that's a big mystery.
It is.
Okay, so the addendum focuses on gravity A,
Okay.
as described by Lazar. Again, doesn't require element 115 to actually exist.
Mm.
Then it goes into all these different
Yeah.
element 115 isotopes,
Yeah.
ones scientists have actually made and some that are just theoretical.
Yeah.
I noticed that Storti uses a mass density
Okay.
for element 115
Right.
that another scientist, Burkhard Frick, estimated.
Okay.
He's assuming this applies to the heaviest
Right.
element 115 isotope at the time, element 115 isotope 290.
Yeah.
Have they synthesized any heavier isotopes since then?
Yeah. They have.
Okay.
But the paper does acknowledge that.
Okay.
Is that the tables would need minor adjustments
Okay.
if and when heavier isotopes are synthesized.
So it's still relevant.
It is.
Let's get back to gravity A.
Sure.
The paper's got all these equations.
Yeah.
Can you walk us through equations 1, 2, and 3?
Sure.
It seems like Storti's trying to calculate
Yeah.
the minimum and maximum frequencies
Yes.
for these gravity A waves coming from the element 115 nucleus.
That's right. A little lost.
Okay, so equation 1, that defines the minimum frequency
Okay.
of gravity A waves
Uh.
coming from the nucleus of element 115.
Okay.
Think of it like the lowest possible note
Right.
that this element can sing in terms of gravity waves.
Yeah.
And this minimum frequency,
Yeah.
it depends on a few things.
The mass of the nucleus, a radius where quantum vacuum effects start becoming important, and some fundamental constants in physics, like the speed of light
Yeah.
and the gravitational constant.
Okay, so far so good. What about equations 2 and 3?
Yeah, so those deal with the upper limit
Okay.
of these frequencies.
Right.
So equation 2 introduces something called the quantum vacuum cutoff frequency.
What?
It's essentially like a speed limit for these waves in the quantum realm.
The speed limit.
Yeah.
Okay.
And then equation 3 defines this cutoff frequency.
Okay.
It's based on the Compton frequencies
Uh-huh.
of the proton and the electron.
All right, so Storti has defined the minimum and maximum frequencies
Yeah.
for these theoretical gravity waves.
Yeah.
So does this mean Lazar was right?
Well, here's where it gets interesting.
Right.
Despite all this stuff about gravity A,
Yeah.
Storti actually argues that there's only one type of gravity,
Okay.
which goes against Lazar's claim that gravity A and gravity B are separate forces. Storti is proposing that what Lazar calls gravity A is just gravity but at the atomic level described by the quantum vacuum.
So is he saying that Einstein's theory of general relativity, which explains gravity on a large scale, is wrong?
It's not about being right or wrong.
All right.
Think of it this way. General relativity is kind of like a powerful martial art.
Right.
Works great for large-scale battles. But then you have the quantum vacuum approach. That's like a more refined martial art, effective at the atomic level.
Gotcha.
He's saying we need this quantum theory of gravity to really understand this force. And that the quantum vacuum is a good way to explore that.
Interesting. Is the scientific community on board with this?
Well, it's a bit of a debate. In modern physics. I mean, general relativity has been really successful on large scales, like planets and stars, but it kind of breaks down at the quantum level.
Right.
So Storti's argument is definitely thought-provoking, but it's still being debated.
So what Lazar thought were two types of gravity might actually be just one, but operating differently at different scales.
That's what he's suggesting.
Okay, to understand his reasoning, we need to get into his analysis of different element 115 isotopes.
Right.
This is where tables 1 and 2 come in, right?
Yeah, exactly. Tables 1 and 2 present his analysis of element 115 isotopes. And he's categorized these into solutions that align with what's called the island of stability.
Hold on. Island of stability.
Yeah.
What does that mean?
Okay, so imagine a map of all the elements, right?
Right.
Arranged by their number of protons and neutrons.
Okay.
The island of stability, it's this region on the map where certain super heavy elements are predicted to be surprisingly stable, like way beyond what we've been able to synthesize.
So how does this island of stability relate to element 115?
Well, element 115, also known as moscovium,
Uh-huh.
it's thought to reside on this island of stability.
So if element 115 is on this island, does that mean Lazar's claims about its stability are more believable?
It's one piece of the puzzle,
Okay.
but not the whole picture.
Right.
In Table 1, he breaks down his analysis.
Okay.
He lists element 115 isotopes
Right.
from 286 to 301.
Okay.
And highlights 3 specific isotopes.
Okay.
290, 296, and 299.
What's special about these isotopes?
So 290 is what he calls the Frick solution.
Well,
that's based on that mass density we talked about before.
Right.
Then isotope 296, that's Storti's own solution.
Okay.
And he thinks it best fits the island of stability based on his calculations.
Gotcha.
And then 299, that's a solution derived from standard nuclear physics theory.
Okay, so 3 different isotopes.
Yeah.
All potentially on this island of stability.
Right.
And then to make it even more complicated, he includes figure 1, a visual guide to locate these isotopes on a chart of the island of stability.
Right.
Right. And then we move on to table 2.
Yeah.
List 3 more.
Right.
Element 115 isotopes, 258, 272, and 317. Why are these important?
Those are theoretical, meaning they haven't actually been made yet. He includes those to explore possibilities outside the island of stability and standard nuclear physics.
So he's saying, what if we don't know everything?
Exactly.
Okay, so he's got all these isotopes, some real, some theoretical.
Right.
Where does he go from there?
That's where table 3 comes in.
Okay.
It's an average solution across all those isotopes in tables 1 and 2.
So it's kind of like a benchmark.
Yeah.
Representing the average gravity A characteristic.
Yes, exactly.
Based on all these isotopes. Why is this benchmark so important?
Because it lets him assess the claims made by another researcher, Paul Edwin Potter, about the sports model craft described by Lazar. And here's the interesting part.
Okay.
The calculated gravity A frequency in Table 3 lines up with Storti's previous calculations from his earlier paper on gravity B.
So I've got consistency.
We do.
That's got to be a good sign.
Yeah, consistency is a positive sign.
Okay.
It suggests that his method for analyzing Lazar's claims might be on the right track. Even if the conclusions are unconventional, this is getting kind of dense.
Yeah, maybe we should pause here and pick this back up in part 2.
Sounds good.
I think our listeners could use a break.
Yeah, probably.
We've covered a lot.
We have.
Yeah.
Yeah, it is a lot to absorb.
It really is.
For sure.
All right, so those of you who are still with us after that deep dive into isotopes and quantum vacuums, congratulations. You're officially science enthusiasts.
Uh-huh.
Picking up where we left off, Storti uses this benchmark
Okay.
from Table 3 to analyze the work of another researcher, Paul Edwin Potter.
Okay.
Potter really focused on what Lazar called the sports model craft. For those who might not be familiar, could you give us a visual? What does that look like?
Picture a disc-shaped craft
Okay.
with a central reactor on top and 3 gravity amplifiers underneath.
Like a flying saucer?
Kind of, yeah, like a classic flying saucer.
Right.
From those old sci-fi movies.
Right. And according to Lazar, these gravity amplifiers use element 115 to create the gravity waves that allow the craft to move around.
That's the idea.
Potter tried to calculate how much power these amplifiers would need based on Lazar's descriptions.
Right.
What did Storti find when he compared Potter's calculations to his own findings?
Well, he noticed a couple things.
Okay.
First, he pointed out that Potter used an incorrect value for the gravitational constant G in his calculations.
Seems like a small detail.
Yeah, you might think so.
Yeah.
But it can actually have a big impact on the results.
So even a small error in physics can really throw things off.
Exactly.
So using the correct value for G, how do those revised calculations compare to Storti's findings?
Even with the correction, there's a big difference.
Okay.
Storti found that Potter's power estimate for the gravity amplifiers is way higher than what his own calculations suggest.
Like how much higher?
We're talking orders of magnitude higher.
Wow.
It's a huge discrepancy.
So is Storti saying that Potter's work is totally wrong?
Well,
or that Lazar's claims are inaccurate?
It's not that clear-cut.
Okay.
Remember, Potter is working with limited info. He's relying heavily on Lazar's descriptions, which may not be perfectly accurate.
That's true.
So we got to keep that in mind.
Yeah, Lazar's claims are hard to verify.
Yeah, it's
all a bit of a mystery, isn't it?
It is a bit of a mystery.
Yeah.
And there's another thing to consider.
Okay.
Potter's calculations assume that all 3 gravity amplifiers are running at full power all the time.
Okay.
But Lazar himself said that the craft usually only used 1 or 2 amplifiers, saving full power for really intense maneuvers.
So if we take Lazar at his word, Potter's power estimates could be way off.
Could be, yeah.
Yeah.
If those amplifiers are usually running at lower power, the difference between Potter's results and Storti's calculations would be smaller.
It's like saying your car's always running at top speed.
Yeah, exactly.
Even though you're usually just driving around town.
Right.
Makes sense.
It's a good analogy.
So where does all this leave us? Has Storti proven or disproven?
Not really.
Lazar's claims.
His addendum.
Yeah.
It's more about exploring the physics, highlighting the possibilities, and the limitations of what we know.
Okay.
He gives us a framework for analyzing these claims, but we don't have any firm conclusions.
So we're still in the realm of scientific speculation.
To a certain extent, yeah.
Okay.
But even speculation, when it's grounded in scientific principles like this, can be valuable.
Okay.
It makes us question what we think we know and explore new ideas. It's like a good mystery novel.
I like that.
Keeps you guessing.
A scientific mystery novel. But I'm sensing a but coming.
Well, there are still some unanswered questions that the addendum doesn't really address.
All right.
For example, Storti mentions the idea of a quantum vacuum thruster.
Oh, yeah, I've heard of those. Aren't those like the holy grail
Pretty much.
for space travel?
Yeah, tapping into zero-point energy.
Right.
No fuel, unlimited energy, theoretically.
It sounds too good to be true.
It does, yeah. And the scientific community is divided on whether they could even exist.
But Lazar claimed that the sports model used something similar, right?
Right. He said it harnessed that quantum vacuum energy by manipulating element 115.
Okay, but Storti doesn't really go into detail.
No, not really.
About how such a thruster would actually work.
Right. He focuses more on analyzing element 115 and how it might interact with gravity.
So, although Storti's addendum doesn't prove or disprove Lazar's claims, it does open up
Yeah, it does.
Some really interesting possibilities for research.
It does.
It's like he's giving us a glimpse into a whole new world of physics.
It is, yeah.
Speaking of groundbreaking discoveries,
Okay.
Storti mentions this thing called a fuel disk in relation to the sports model.
Right.
What is this fuel disk exactly?
It's described as a circular plate
Okay.
made of element 115,
Okay.
located in the reactor at the top of the craft.
Okay.
And according to Lazar,
Yeah.
this disk is bombarded with protons,
Mm.
which causes it to release antimatter particles.
Antimatter. That's sci-fi stuff, right?
It sounds like it, yeah.
Yeah.
But it is real.
Okay.
It's just incredibly difficult to make and contain.
And matter and antimatter destroy each other on contact,
That's right.
releasing a ton of energy.
A huge amount.
Yeah.
But theoretically, if you could control that process, you could harness that energy for propulsion.
Right.
Yeah, it'd be a revolutionary energy source.
So how does this fuel disk fit into Storti's analysis?
He did some calculations
Okay.
to figure out how thick
Yeah.
this disk would need to be
Right.
based on the properties of element 115.
Okay.
And this thickness, he calls it T115 in
Right.
his tables. That's a key factor in determining if Lazar's claims are realistic.
Okay. And what does he find?
It depends on which isotope of element 115 is being used.
Okay.
Some isotopes would need a thin disk, while others need a much thicker one.
And which scenario is more likely?
Unfortunately, Lazar didn't say how thick
Right.
the fuel disk was supposed to be,
So they don't really know.
so it's hard to say.
Yeah.
But Storti points out
Okay.
that a thicker disk
Yeah.
would be harder to make and handle,
Right.
which could pose some big challenges.
Yeah. We're talking about handling antimatter.
Right, exactly.
That's not something to mess around with.
Definitely not.
So even if we assume Lazar had element 115,
Yeah.
making this fuel disk
Right.
and using it safely would be incredibly difficult.
Very difficult.
Wow. This deep dive has given us a lot to think about.
It has.
I bet our listeners have a ton of questions.
Probably.
Should we take a moment?
Okay.
And then come back
Yeah.
for a final wrap-up.
Sounds good.
Welcome back to the deep dive. We're wrapping up our look at Robert Lazar, element 115, and the possibilities of alien spacecraft propulsion.
It's been a wild ride.
It has. We were talking about the quantum vacuum thruster
Right.
before, that theoretical engine
Yeah.
that could tap into the energy of the quantum vacuum.
Mm-hmm.
Does Starty think we could actually build one?
He doesn't say for sure.
Okay.
He acknowledges it's theoretically possible,
Mm-hmm.
but there would be a lot of challenges.
Yeah, like how do you even start?
Right.
It's like something from Star Trek.
It does sound like
Manipulating the energy of the
Yeah.
quantum vacuum.
It's a really out there concept.
It pushes the boundaries of what we know about physics.
It does.
And Lazar claimed that the sports model was already doing something similar.
That's right.
He said it was warping space-time,
Yeah. Those claims are
Yeah.
pretty extraordinary.
to say the least. It would completely change our understanding of the universe.
It would.
That's why we need researchers like Storti,
Absolutely.
who are willing to take these claims seriously
Right.
and analyze them
Yeah.
from a scientific perspective,
It's important.
even if they sound crazy.
It is.
Storti also talks about the bigger picture,
Yeah.
the implications of this technology for society.
He does.
Can you tell us more about that?
He says that if this tech were to become real,
Yeah.
it could have huge benefits,
Okay.
but also potentially disastrous consequences.
Right. The power to manipulate gravity
Yeah.
and travel faster than light.
It's a lot of power.
Yeah.
Could be misused.
The stakes are high.
They are.
So after all this,
Mm-hmm.
do we know for sure if Lazar's claims are true?
I'd say
Yeah.
Storti raises more questions than he answers.
Okay.
His analysis shows
Yeah.
that some of Lazar's claims might be possible, but there are still inconsistencies.
Right. It's like a puzzle where we only have a few pieces.
Exactly.
We see glimpses of a picture, but not the whole thing.
Right, and that's what makes this so fascinating.
It is.
It leaves us wanting to know more.
Yeah. And that's the end of our deep dive into Robert Lazar, element 115, and the possibilities of alien tech.
It's been a pleasure.
It has been. Thanks for joining us. Keep exploring, keep questioning, and until next time, keep diving deep.